Hi everyone, so today we're going to be working on this problem. A sample of fluorine 18 has an initial decay rate of 1.5 times 10 to the 5 disintegrations per second. How long will it take for the decay rate to fall to 2.5 times 10 to the third disintegration per second? Fluorine 18 has a half-life of 1.83 hours. So we're going to need to remember these two equations. Ultimately, we're going to need to find time t, but to do that, we're going to need to know our k, our rate at time t, and our initial rate. We're given our initial rate. That's 1.5 times 10 to the fifth. And we're given our rate at time t. That's 2.5 times 10 to the third. But we're not given k. We're given a half-life. So we're going to use this half-life formula and rearrange to solve for k and plug this k value into this formula to find time t. So let's do this problem. We're given our half-life. That's 1.83 hours is equal to 0.693 over k. To rearrange to solve for k, we're going to have to multiply k to both sides and divide by 1.83 hours on both sides. Simplifying this, we're going to get k is equal to 0.379 per hour, or hours to the negative 1. Now we're going to need to take this k value, plug it into this equation, and rearrange to solve for t. So we found our k, 0.379 per hour, or hours to the negative 1, times t, equals the natural log of the rate at time t, 2.5 times 10 to the third disintegrations per second. Divide that by your initial rate, 1.5 times 10 to the fifth disintegrations per second. So simplifying this, we're going to get negative 0.379 hours to the negative 1 times t equals negative 4.09. So to find t, we're going to need to divide by negative 0.379 hours to the negative 1 on both sides. The negatives will cancel, and hours will be left on top. So plugging this into the calculator, you're going to get your time as 10.8 hours.